In this lab, we're going to demonstrate the use of PBR Service Graph to redirect the traffic between different EPGs and between the same endpoints in the same EPG to the firewalls. The way we're going to do that is using VZN. VZN is basically a contract that is assigned or that is associated with the VRF. So any EPGs under that specific VRF instance will be matched by the VZN contract. So my contract basically will apply to any IP traffic, so that the traffic between the same endpoints and the same EPG has to be inspected by the firewalls, has to be redirected by the service graph to the firewalls, and also traffic between the web EPG and the DB EPG has also to be redirected to the firewall for inspection. So let's go to this VM. If I'll do config, you can see that it has 10.1.0.1.1, that's a /16 subnet, and doing the same on the other VM. You can see that this one has a 10.1.1.1.0.2, and that's also on the same mask, basically /16. So those two top VMs are in the same EPG, and I have one VM here, and this one is on a different subnet, and that's basically the DB EPG, that's 10.2.0.1.0.3. So let's do some tests. Let's ping traffic between the same EPG, traffic from that VM to that VM, and both of them are on the same EPG. So let me start by pinging this one, 10.1.1.1.0.2, and let's ping, and we are receiving response. And let's also ping the DB VM, so that's going to be 10.2.0.1.0.3, and we are also getting response. So just to demonstrate an actual traffic here, let me SSH also this VM on the left side to that VM. They are in the same EPG, so 10.1.1.1.0.2, and you can see we are receiving a response. And you can see we are receiving a response, and we managed to log in. Doing the same thing to the DB. So from that VM inside the web EPG, I'm gonna SSH to a different VM, a different EPG. So that's gonna be 10.2.0.1.0.3, and we should get a response. So I'll try to log in, and that should work. Yeah. Okay, so we tested the traffic. That's intra EPG traffic and inter EPG traffic, and everything seems fine. However, we need to check if the traffic was indeed redirected to the firewall for inspection. I have one access control policy permitting any, nothing much. So before looking at the events, I'm just gonna jump to the objects. In terms of API integration between the ACI and the FMC, the API controller can use the northbound API to create objects, network objects in the FMC, and it can also notify or update each of these network objects with the relevant learned endpoints in the relevant EPG. So going back to my analysis events, we should be able to see pings, and we should also be able to see SSH traffic. So if you recall, traffic from 10.1.0.1.1 and 10.1.1.1.0.2, these are intra EPG. So let me just go here. So you can see we have on the top, we made an SSH session, and you can see that it's showing. That's from the an endpoint in the web EPG doing SSH to the endpoint in the DB EPG. If I jump to this line, for example, you can see that I'm trying 10.1.0.1.1, which is in the web EPG, is also trying to ping another endpoint in the same EPG. So if you recall, these two are a /16 subnet, so they are on the same subnet basically, and you can see that traffic is flowing to the firewall for inspection. So to demonstrate the ACI and the FMC integration, I'm just going to create one rule, and that rule should deny ICMP traffic between the endpoints in the same EPG. So basically, I'll deny ICMP for any traffic internally within the web EPG. I'll insert this rule above the default rule. I'll select the EPG that the APIC has created, and this one represents the web EPG. I'll add the source and also to the destination, and going to log the connection so that we can see the block event in FMC. So instead of blocking the ICMP, let's actually deny all the intra-EPG traffic within the web EPG. So I will not add any protocols under the application tab. And once it's done, we can do some tests. Now that the policy has been deployed, let's do some tests. So I'll try to ping the other VM in the same EPG. That's 10.1.1.2, and we should not get a response. That's fine. But let's try to ping the VM in the DB EPG. That's 10.2.0.1.3, and we should get a response. Alright, so let's go and check the FMC events, and we should see the allow and the blocked traffic logged in the FMC console. So here we can see that traffic from the web EPG to the DB EPG has been allowed, but traffic from that host in the web EPG to the other endpoint in the same EPG has been blocked by according to our firewall policy. So looking at the APIC, I have my web EPG, I have my DB EPG. The endpoints are being learned in both. So in the web EPG, I have my 2 VMs learned, and the DB EPG, I have also my DB VM learned as well. So moving forward, we have the bridge domain, nothing much, and I have my internal VRF configured here. And under the EPG collection for VRF, I'm applying a VZNA contract to redirect any traffic between the different EPGs to the firewall. So we can see that we have this contract, any IP, it's being used as a consumed and also as a provided contract. And if I jump to this any IP contract, you can see that it is associated with a service graph that will redirect the traffic to the firewalls. Within each EPG, I also have an intra-EPG contract, and that contract is basically redirecting traffic between the same endpoints, the same EPG towards the firewalls. So you can see that the same contract I use for the VZNA is also used as an intra-EPG contract to redirect the traffic to the firewalls. Aside from that, I have my service graph deployed. So that's the service graph that will redirect the traffic to the firewall.